Okay, welcome back. This is 6.4, factoring special forms. So, get this thing fixed. Okay, so let's take a look. Section 1, difference of squares. Okay, so notice what happens when you FOIL the following. So we have x plus 8 times x minus 8. Okay. You're going to do your first outer, inner, last. So first x times x is x squared. Your outer minus 8x. Your inner plus 8x. And then your last minus 64. Okay. So the the inner and outer terms will cancel with each other. They add away. And you're just left with two terms, x squared minus 64. Okay. So it's different than the ones we've been dealing with. All the ones we've been dealing with have been of the form like ax squared plus bx plus c. So there's always been three terms there. So this is, for that reason, considered a special form. And in general, we'll note if you're given the form a squared minus b squared, you can automatically factor it as x, or rather a minus b times a plus b. Okay, in order to do these, it's good to have kind of a list of perfect squares sitting somewhere next to you, or have them memorized. Most people don't have them memorized, so we'll just remind you, 1 squared is 1, 2 squared is 4, okay, and so on, 3 squared. Oops. We'll put one more in there. Okay. After a while, you do enough of these, you'll kind of have them. You'll be familiar with them, and it won't be a matter of having to look something up. It's just, oh, that's a perfect square. Okay, so let's go ahead and take a look at some of the factoring problems then. There's number 2, we have x squared minus 16. Okay, so we can use this as kind of a template. It's a lot like what we did before. You just set up your parentheses. For these kind, it always has to be minus plus, or if you'd rather plus minus, it doesn't really matter, so long as one is plus and the other is minus. And then you need to go x times x to give you the x squared. And then for the 16, you're going to need 4 and 4. Okay. And of course, still you want to be in the habit of doing these in your head, foiling them out in your head. And, first x squared, the outer minus 4x, the inner plus 4x, and the last minus 16. And sure enough, these are additive opposites, so they'll go away, and you're just left with x squared minus 16. Let's look at 6. We have 9x squared minus 25. Okay. So set up your parentheses, get your signs. And 9 is a perfect square, so it looks like we're going to need 3x and 3x. And then 25 is just 5 squared, so we need a 5 and a 5. And FOIL it back out, make sure it works. 9x squared minus 15x plus 15x minus 25. And sure enough, these cancel, and you're left with what you started with. Okay, let's keep going. So I've got a couple more. Here's 8. Okay, this time we don't have the variable term first, but it's still going to work exactly the same as the previous problems. So you can go plus minus and kind of go what times what is 16? 4 times 4. And then what times what is x? Well, x times x. FOIL it back out, make sure it works. And it does. Let's look at one with multiple variables. So 16, 49y to the 4th minus 25. Okay, so they're both, you see they're perfect squares. 7y and 7y. And the other one will be 5 and 5. FOIL it back out, make sure it works. Whoops, I guess I said it was going to have multiple variables. I lied. The next one will. Sorry about that. Okay. Those, again, cancel out and we're good to go. So let's look at one now. Honestly, it has multiple variables. Number 22. You have x to the 14th minus y to the 4th. Okay. So to set it up just like before, it has to be plus and minus. And then to get 14, you're just going to go x to the 7th and x to the 7th. Okay, so remember, when you have like bases and you multiply them, so a to the x times a to the y, you in fact are adding, sorry you can't see that, when you have a to the x times a to the y, you have to add the exponents to get the result. So this would be a to the x plus y. Okay. So when you multiply x to the 7th times x to the 7th, you're going to get x to the 7 plus 7, which will be the x to the 14th. And then similarly, we'll need y squared and y squared. Let's FOIL it out and make sure it works. So x to the 7 times x to the 7 is x to the 14. And then minus x to the 7 times y squared plus x to the 7th times y squared minus y to the 4th. Because you're going to add the 2's, you get y to the 4th. Okay. So the middle two will add away. This will be x to the 14th when you add the exponents. This will be y to the 4th, and of course that's what we wanted. Remember to factor out your GCFs first. So that's always your first sort of law or your first rule. Remember to factor out your GCF first. Okay. So in particular, let's look at 30, and we have 2x cubed minus 8x. So you're thinking about what's the biggest number that divides into both of them, and it seems it's 2x. Okay, so we can pull a 2x out. We're left with x squared and then minus 4. And then we could factor this part because it's a difference of squares. So don't forget the 2x. It still comes along for the ride. And then we're writing up our parentheses. Has to be plus and minus. And then x, 2, 2. And we should be good to go. Okay, so you'll be going along and you'll encounter something like this, x squared plus 4. This one isn't factorable. Okay, so if you go back and look through your notes, or my notes, and consider all of the binomials we've been factoring, they all have minus signs in them. I don't know why this one has parentheses on it. Sorry about that. But they all have minus signs. This is the first one that's had a plus sign. A squared plus b squared is kind of the form. And it turns out you can't do anything with these. If it's a plus sign, you're done. And you're just going to write prime as your answer. There's nothing you can do with it. Okay, let's look at one more. And then we'll go up to perfect square trinomials. So here's 42. I got negative 4x squared plus 4. We have a GCF of 4, but we also want to pull out any negatives. We don't like having those leading coefficients being negative, so I'll pull out a negative 4. I'm left with x squared minus 1. And then I can factor this guy down. So I'll have negative 4 times x and x, so it'll be plus minus 1, 1. Okay, so that's our first form. Let's look at the next type, the perfect square trinomial. Okay. So what is the deal here? Well, notice what happens when you sort of FOIL out the following. Okay, so what we were dealing with last time was plus, minus. They had different signs. Now we have, let's say what happens when we have plus, plus. Okay. So x squared, the outer, 5x, the inner, 5x, and then the last, 25. Okay. If we combine this, it's going to be x squared plus 10x plus 25. And it's a form, okay? And it's particularly a form because this thing's always going to be a perfect square when this happens. And then this thing is going to be the sum of those squares, right? So this is 5 squared. And then this thing here is the 5 plus 5, gives you the 10. Okay. So in general, we have some more forms. We'll have a squared plus 2ab plus b squared is the case when you have a plus b times a plus b. And the other case is when it's a minus b times a minus b. So it'll be a squared minus 2ab plus b squared. It'll be a minus b times a minus b. Right. In all reality, though, in the real world, in practice, I don't have this form memorized at all. I just do trial and error, and I'm particularly hopeful it'll be one of these perfect square trinomials because they're typically the easiest to factor. Okay, as soon as you see that perfect square on the end, you're hoping it's x plus 5, x plus 5. That's the easiest thing. Okay, so let's take a look at it anyways. So 48, you have x squared minus 10x plus 25. It's almost exactly the same problem we just did up here, except instead of plus, it's minus. So it'll be, set up your parentheses. You have to have x and x. The signs, I mean, even without knowing the forms from our previous work, we know it has to be minus, minus to get the last term to be positive and the outer and inner term to add to a negative. It has to be minus, minus. Then you're thinking two numbers that multiply with 25 but add to be 10. And obviously 1 and 25 isn't going to work. So it has to be 5 and 5. And this turns out to be a perfect square trinomial. As usual, FOIL it back out, make sure it works. Let's just move on. Here's 56. So I have 64y to the second minus 16y plus 1. Set up my parentheses. It has to be minus minus again. 64 is a perfect square. 1's also a perfect square, so we know it has to be 1 and 1 here. But 64 in particular, you're thinking 8 and 8. You hope it's 8 and 8. You know? Otherwise, you may have some work to do factoring. Maybe 12 and, I don't know, 32 and 2, or 64 and 1. So you hope it's this. Okay, let's FOIL it back out and see if it worked. And of course, we have the first 64y squared, the outer minus 8y, the inner minus 8y, and the last plus 1. And sure enough, 8y and 8y is the 16 that we're after, so this works. What else they got for us? Here's 58. I got x squared minus 7x plus 49. Okay, so we're, as usual, we're hopeful it's x minus, and then 7 and 7. And it turns out this one isn't going to work for us because if you add 7 and 7 together, you're going to get 14, not 7. The only other possibility is 1 and 49. And certainly if you add 1 and 49 together to get the middle term, you're going to get 50. Or if you subtracted them, you get 48. You know, any way you slice it, you're not going to get a 7. So it's really, you know, I don't know what goes in there. And when you don't know, you're going to be left with just calling it prime. There's, for us, at this point, there's no way to factor it. Let's look at a multivariable one. Okay, so as usual, we're hopeful it's a perfect square version. So x and x, again, minus and minus. Then, you know, 9 times 9 is 81. So we hope it's 9 and 9. And of course, it's multivariable, so we want to slip a y in there as well. FOIL it out, see if it works. X squared minus 9xy minus 9xy and plus 81y squared. 9 and 9 is 18. Yeah, it worked. Remember to always factor out that GCF first. Let's look at number 78. So this one is a mess. It's negative 45y cubed minus 30y squared minus 5y. So I want to factor out a negative first off. I can factor out a y. And then it looks like each one has a factor of 5. So negative 5y. The leftover parts, we have a 9y squared plus 6y, and then plus, I guess, 1. We can go further, so I want to FOIL this thing, or sorry, factor it. The signs are plus and plus, so these signs must be plus plus. 1 times 1 is 1, and we're hoping it's a perfect square trinomial, so 3y times 3y is 9y squared. And then factor it out, see if it actually works. So 3y times 3y is 9y squared. The outer plus 3y, the inner plus 3y, and then the last. And sure enough, we get back to what we wanted. Okay, so I think it works. Okay, the last form is the sum and difference of cubes. And let's take a look. So these formulas you generally have to memorize. So sum and difference, I'll abbreviate difference, DIFF, of 2 cubes. Okay, so let's look at the forms first. A cubed plus B cubed equals A. And there's a way of remembering the signs that we're going to be using here. B goes here. So it's called SOAP. You use the same sign and then the opposite sign and then always positive. Okay, so SOAP. Same, opposite, and then always positive. So again, it's you use the same sign and then take the opposite sign and then the last place, it's always going to be positive. Okay. Then the rest of it, you're going to have a squared, excuse me, and then ab, and then b squared. So that's the sum of cubes. Then you also have a difference of cubes to remember, which is a minus b times, we have a squared, ab, and then b again, b squared. So this time the signs same, opposite, so it'll be plus, and then always positive. Okay, so when I do these, I kind of identify what is A, what is B, and then use the forms as a template for filling in the blanks. So let's look at 82. We have x cubed minus 64. Okay. So the signs, same, opposite, always positive, and then I need to put A here, B here, A squared, A times B, and then B squared. Okay, so what is A? Well, A is, and later we'll call it the cube root of x. So what times what times what gives you x cubed? And that's just going to be x. And then B is basically the cube root of 64. So what times what times what is 64? And you may want to write out a list of perfect cubes. And so if you had a list, you would see that 4 cubed is 64. Okay. I don't include the sign on any of these. The sign material is kind of embedded in these signs. So I don't have to worry about, oh, let's make B -4 or something. No, you don't worry about that. These are both going to be positive. And then I just fill in the blanks with what I need. So I need to put A here, B here, A squared here, A times B here, and then finally B squared here. Let's look at another. So this is 86. I have 125x cubed plus 8. Okay, so it's same sign, opposite, always positive. And it'll be AB. I need A squared here, A times B here, and then B squared. So I asked myself, what times what times what is 125x cubed? That's going to be 5x. And then what times what times what is 8? It's just 2. Okay, and then I fill in the blanks. So A is 5x, B is 2. A squared is 5x times 5x. So it's 5x squared, which turns out to be 25x squared. A times B is 5x times 2, which is 10x. And then B squared is just going to be 4. Okay, one more. So here's 90. I have 64y minus y to the 4th. Okay, so for this guy to work, you notice it doesn't have like a cube in here. You have to factor out the GCF first. So it's always a thing, you know. You're always looking for GCFs, and here y can be factored out of both. And it's a difference of cubes. So I'm going to set up my parentheses. Okay. The same sign, opposite, and then always positive. I'm going to smush this in. The A is 4. 4 times 4 is 16 times 4 again is 64. And then my B value is y. So I need A minus B, and then A squared is 16, and then A times B is 4y, and then finally B squared is y squared. Smush that in there. Okay, so that's it for this section.